Okay, so here in question 8, we are working on a vectors question. It's not variable acceleration, don't be tricked by that. There is no t variable inside any of these vectors. It's just a standard SUVAT question, but using vectors. So we'll go ahead and fill in the information that we know. So we know the displacement, we know the initial velocity, we don't know the final or the acceleration, and we do know the time. We're looking for acceleration, so we just want to make sure we choose the formula that will help us to calculate acceleration and uses the variables we have. So S equals ut plus half at squared. Filling in all of those values. Okay, and that all leads down to an acceleration vector of 1.5, -2. The question has asked us to find the magnitude, so we'll employ some Pythagoras, and that leads to 2.5 meters per second squared, which, given this was a show that question, we know is correct. Okay, so in part B, we're told that the instant P leaves A, the acceleration changes, and we want to find the time that it takes for the particle to get from A to B. Well, the velocity at the end of the initial movement, so the movement up to A, we should be able to find. So using the variables we had previously, we can go ahead and find the final velocity for that first stage. So V equals U plus AT, put those in. So the final velocity of that first stage is 5, -7. So that's the velocity at point A. So if we now think about the second part of the journey from point A to point B, we want to get an expression for the velocity there. Not interested in displacement, and we don't know it, but we do know the initial velocity at A. Unsure of the final velocity is what we're trying to find. The acceleration is given to us in the question, it's 4 and 8.8, and the time we'll also be trying to find as well. Okay, so an expression for the final velocity, or the velocity at any point on this journey, we can get an expression. And that expression is 5 plus 4t for the horizontal component, and -7 plus 8.8t for the vertical component. Since we're told that point B, the direction of motion is northeast, that means that the velocity vector is going to be northeast. And we know that means the horizontal and the vertical component should be the same as each other. So that helps me to set up an equation that I can solve. And just some quick rearranging, solving for t. Let's just fix these should have been plus 8.8. Some quick rearranging and solving for t. We get that t equals 2.5. So the time taken to move and travel from A to B is 2.5 seconds.